Okay, Team Bio, welcome to your screencast on biomagnification. So, quick review, we've talked about how nutrients cycle through an ecosystem from the producers up through consumers and then to decomposers and back into the ecosystem. And we've also talked about how energy is flowing through the ecosystem and the 10% trophic rule at every level of the ecosystem. As we move up a trophic level, 90% of the energy is lost as heat and 10% is retained as chemical energy in the biomass of that trophic level. So energy is lost at every trophic level here. And this is related to our topic today, biomagnification, because we're seeing the opposite happen here with toxic nutrients. So let's get right to it. Biomagnification, what is it? Well, it's when the concentration of toxins in an organism as a result of ingesting other plants or animals are highly concentrated. I want to rephrase that. The concentration AI of toxins in an organism as a result of eating other organisms in which the toxin is more widely distributed. So what does that actually mean? I'll give you an example. Okay, PCBs. These are components of electronics that were common until about, I think it was 1977. They were banned from use in electrical equipment. But these components, organic components, still can leach out of electronics that have been sent to landfills. So PCBs can enter water systems. PCBs are toxic and they cannot be broken down by the organisms that ingest them. So they remain in the bodies of the organisms that take them up. They are taken up at the very base of the food chain by phytoplankton. So phytoplankton are a broad group of organisms that all have one thing in common. They are doing photosynthesis. Oops, there's an S in there. And they can take up very small concentrations of PCBs, and they remain in the bodies of these organisms throughout their lifespan, but they're such low concentration that they don't necessarily do a lot of damage to these phytoplankton. However, as we move up the food chain to zooplankton, for example, which are eating some of the phytoplankton as well as smelt, we see a magnification of this toxin because the zooplankton is eating a bunch of phytoplankton and they can't pass or get rid of the PCBs that they consume. And the same is true even to a higher extent in the smelt. So as we move up the food chain, we start to see a higher and higher concentration of PCBs in every single organism until we get to the top predator, the herring gull, which has a super high concentration of PCBs in its system. And this is a problem because this leads to really fragile, delicate eggshells, and led to the crash of herring gull population. Um, we also have seen this happen with a bunch of other toxins, like DDT, which led to the collapse of the bald eagle. And we see this happening in oceans with mercury. So this is an issue for top predators, and as such, it's an issue for humans. If the food that we are eating has low concentrations of um, toxins that are aggregating in us, it can lead to long-term health consequences. So consider limiting the amount of tuna that you're eating because it can have high concentrations of mercury. Okay, that is all on biomagnification. See you all in class a week from now on Thursday.